Thank you so much. Again, this is Elaine Arkin. Good afternoon to everyone. I'm moderating today's NCCOR Connect and Explore session. Today's program is about the Youth Compendium of Physical Activities, its development and its use, and we're looking forward to this second in a series. This is an NCCOR-led initiative with NCCOR providing funding and support for the project. Our speakers will focus on the revised Youth Compendium of Physical Activities, on data sources, activity codes, and metabolic intensities, and the use of the compendium for tracking physical activity in youth. And following their presentations, we'll have a one-on-one question and answer session so that you can ask questions of the speakers. And then at the very end, there'll be a few NCCOR announcements. Now, if you have a question for our speakers during the presentation, please write it in the chat box on the right side of your screen. You can see where the arrow is pointing. If you need technical assistance, please let us know using that same chat box. If you're having trouble logging onto the webinar but can hear us on the phone, you can email us at NCCOR@fhi360.org, and we'll work with you to resolve the problem and get you on the webinar. And one more final important technical note. If you've decided to listen to our webinar today using your computer speakers, please turn down or mute the computer microphone. This will greatly reduce the potential for background noise. And thank you so much for that. Now, we'll also be live tweeting during today's webinar. If you're on Twitter or other social media, we encourage you to join the conversation using the hashtag ConnectExplore and following the Twitter handle at NCCOR and on Facebook at NCCOR.org. Our speakers today are Karin Pfeiffer, Associate Professor of Kinesiology at Michigan State University. Karin will define appropriate metrics for youth energy expenditure and age dependency. Nancy Butte is a Distinguished Emeritus Professor at Baylor College of Medicine, and she'll share background on the development of the compendium. And finally, Scott Crouter is an Associate Professor of Exercise Physiology at the University of Tennessee at Knoxville. Scott will share how the compendium can be used by a variety of audiences to measure physical activity. Now, just before we get started, we would like to share a brief poll. If you could just check right on your screen the description of you that best fits, just to give our speakers an idea about who's on the phone today. I see we have a lot of researchers and educators, a lot of other. So thank you all for giving us a little bit of information about yourselves. And now I'd like to turn it over to Karin Pfeiffer for our first spotlight segment. Karin?
Thank you, Elaine. Good afternoon. Thanks, everyone, for joining us today, and thanks to NCCOR for all of the support in setting this up. As Elaine noted, we are speaking about a compendium of physical activities, and just a brief background on that prior to beginning. What is a compendium of physical activities? It is a list of values, and those values note energy costs for all different kinds of physical activity that we can perform. The currency, or the unit, is typically expressed as a metabolic equivalent, also known as MET. And what a MET value is it's the amount of energy expenditure at rest, so a resting metabolic rate. And then activities are presented in terms of how many multiples of rests they might be. For example, if I were running, I would have a higher MET value, around 9 or 10 multiples of resting energy expenditure, versus if I were walking briskly, I might be around 3 or 4 METs of physical activity. The original Compendium of Physical Activities was published in 1993 by Barb Ainsworth and colleagues, and it was originally intended to provide values about energy costs for use with physical activity survey research. Over time, that compendium has evolved and additions have been made and improvements. And on top of that, a youth-based compendium was developed and published around 2008 by Kate Ridley and colleagues. And the compendium that Kate Ridley and colleagues devised had several youth-based values in it. However, about 2/3 of the values still remained as adult-based values in that particular compendium. So what we're going to talk about today is these 5 steps, and I will be telling you about, number 1, establishing the need for a youth compendium, and number 2, determining both the best units or metric to use and how to represent any kind of age factor. I'll turn it over to Nancy, who will discuss the data sources and the development of the youth compendium, and then Scott will wrap it up with applications and limitations. This all started with a workshop back in 2012, and NCCOR folks had the idea to ask this question of, do we need a youth-based compendium? Do we need to extend the work that was originally done? And you can see on the slide a whole host of us. All of our pictures are on there. All of us who are on the call today were part of that original meeting, in addition to several other key individuals. Kate Ridley was also there at this meeting, and Barb Ainsworth as well. What we discussed at this meeting was, do we need to develop something that is a youth-specific sort of compendium, as Dr. Ridley had already started back in 2008. And what happened when we started discussing this issue is a major question arose about, if we did create another revised compendium for children, what would we use as our basic unit that would appear in the compendium? Could we use the adult-based MET and call it a day, or should we do something that's more child-based? And for those who are a little less familiar with what happens developmentally over time with energy expenditure, this figure shows on the x-axis age, and on the y-axis resting metabolic rate. The unit for that is calories per kilogram per hour. And what you can see is, over time, from the younger age groups, around 3 to 5 years, all the way up to 18 and then into adulthood, you can see a decline over time in what is the value for one MET. And you can see at the very end by the 18 where the adult MET lies. And you can see that all of those other data points are various intervals away from that one line that would go across at what is the adult MET value there at the 1. You can see over time that from younger to older, we just decrease. And so does an adult-based MET value really apply to children and adolescents? This figure suggests probably not. So that brought us to, what would we do about units if an adult MET was not appropriate, and how would we really take age into account as we were thinking through this compendium? The ideal metric, of course, would be then age independent, and we realized that we would want it to be mass specific, to have low variance, of course be simple to use if possible, and we wanted it to have some sort of ties to existing measurements so that it would make sense to most individuals who would use the compendium. We decided to examine some previously used metrics that have been reported in the literature, and I won't name every single metric, but you can see that several metrics were considered, and our group decided to do a comparison to really tell us how much age and some other characteristics, height, mass, and sex specifically, would contribute to these particular units. Now, Nancy will talk a little bit more about what we did in terms of pooling data, but we pooled a data set, and Nancy will talk a little bit more about that. And from that pooled data set, we were able to examine how much of the variance we would account for with age, height, mass, and sex. So what you're looking at is across the x-axis all of the different units we examined, and on the y-axis you're looking at the R-square or variance that we would account for. And if you have a high value here, that means that particular metric was very much subject to the effects of age, height, mass, and sex. The three that we have highlighted, which are allometric scaling, net VO2, which is subtracting a resting value from an activity value, and then the youth met, which is dividing an activity value by a resting value, were the three metrics that seem to do the best in terms of not being subject to the effects of age, height, mass, and sex. And so we decided that those needed a little bit further exploration. But in addition to that, even if you take a youth met and you plot it in terms of age, there are some activities, and boys basketball is the example here on the screen. If you look at child mets or youth mets as the unit on the y-axis and age, you can see that even if you use the youth met, which is one of the least subject to issues such as age, height, mass, and sex, we still have a little bit of an issue here where the average MET score across age groups would be about 7, and in a 5 or 6-year-old, it's more around 5 METs, but in a 16-year-old, it's closer to about 9 METs. So you can see that if we were to use one value as a MET value across all ages, it would cause a problem for some activities. Not all, but some activities. So the storyline at that point was that no one metric was optimal. The youth MET does have some pros and cons affiliated with it, as you saw on the previous screen, but the youth MET still was the best metric when we lined it up against all the others. However, we still couldn't completely take away the effects of age just by using that metric alone. So what we decided to do is continue to use our pooled data set and examine 3 approaches to this issue with age. The first approach that we were thinking about was simply, what if we just used one value of a youth MET across all age groups? So that's what we call the constant. The second that we took into account was creating age groups. So we created 4 age groups, 6 to 9, 10 to 12, 13 to 15, and 16 to 18 years, and decided to take a look at the age groups to see how well we could account for age if we broke values into age groups. A third method that we examined was examining one-year increments, so a specific MET value for each age. So one value for 7-year-olds, one value for 8-year-olds, etc. We used regression analysis, and we estimated error for the method 2 and 3, and we compared it to the constant value to see how much % reduction in residual variance we would get if we used an age groups model or an age in years model versus what we would see if we just used one constant value across all age groups. This next figure shows how for an activity like walking at 2 miles per hour, the top left figure is showing, and again, all of the figures themselves will show age across the x-axis and then youth MET values on the y-axis. And the dots represent measured MET values at those ages. And then you can see that the lines show you what we're trying to examine. So the top left figure is showing you if we used a constant value for a youth MET, what would happen? Versus the top right, which is showing you if we used average values for 4 age groups for a MET, versus the bottom figure, which is showing the age specific. So we use one value for each age over time. And what this entire figure shows you is we don't see much difference for an activity such as walking at 2 miles per hour. However, to use our basketball example again, you see that we see a difference if we take age groups into account and or the age specific in the top right or the lower figure. And this is similar to what I showed earlier with the basketball figure. So this means if we were to use one constant value for a MET, we could do some overestimating or underestimating depending on what age group would be involved. So to sum up this portion, and then I'll hand it over to Nancy, we discovered really that the models where age was considered, the age groups model and the age-specific models, had less error than using a constant value for the youth MET. And they showed the best correlations with measured energy expenditure as well. In the end, the youth MET was a fantastic approach for low-intensity activities. As we showed you with walking at 2 miles per hour, did a great job. But a couple things came to light that were feasibility kinds of issues, and that is that people fundamentally understand the value of METs from the adult compendium. And so a MET is kind of that sort of currency of the language that makes sense to people, and it's how the adult compendium is organized. So to have the youth compendium, as it's revised, be similar in units and how it's organized to the adult compendium is generally a little bit less confusing than other methods we could have used. So now I'm going to turn it over to Nancy.
So just as Nancy's getting ready, I just want to remind you, if you have a question, please use the chat box on the corner of your screen. And so now Nancy.
Great. Good afternoon, everybody. In this segment of the presentation, I'd like to review with you the development of the Youth Compendium. And we'll begin with looking at our data sources. As Karin explained, two very important decisions were made by the whole research team. First, that only pediatric data would be used to form the revised Youth Compendium, and that the unit would be the Youth MET, and we would present the data in the four age categories. So our major data sources were threefold. We conducted a systematic literature review that included about 90 studies. We used a pooled individual data set, and these were individual energy costs of various activities that were contributed by investigators in our research team. That had data in their own laboratories. We compiled about energy costs of physical activities from about 933 children. And lastly, our team decided that it might be worthwhile to try to solicit new data from other investigators in the field. And it was actually very successful. We received 17 articles with new novel data. And just a little bit more detail on our data sources. We actually, NCCOR commissioned a literature review by Kate Ridley. As Karin said, she had published a youth compendium in 2008, and she extended that with an additional 71 studies. It included 347 unique energy costs values. And just to give you a feel for what the new data look like, you can see it here in the table. And you can tell recently there were many, many papers on active video games, for instance, as well as sedentary screen time. Our pooled individual data set was, again, data that was contributed from Baylor College of Medicine, from Michigan State, Oregon State, the University of Massachusetts, as well as North Carolina. In this table just gives you a feel for the type of data that was contributed from these laboratories. And lastly, the data that was published in the JPOD supplement yielded data from about 250 activities across a wide age range of 3 to 18 with various sizes of the various cohorts that were used. So the next step was to compile the data from all these three sources and develop the Youth Compendium. And once we had the data compiled, we subjected it to the following 5 steps. The first thing we did was classify all the activities into 16 major categories by the 4 age groups. We then constructed profile plots for the 16 major categories and really scrutinized the data. we looked for outliers, cleaned up the data, and then presented it to our statisticians. We were very fortunate amongst our research team. We had 4 statisticians that were very instrumental in developing the compendium. Looking at the data, they realized that we had a large amount of missing data. So they decided on a multiple imputation model in order to fill in the missing net values for each of the 16 categories. The data was then returned to the entire research team, where again we scrutinized the data to see if it made sense, if it looked well, for both the observed and the imputed values. And the last decision was made that in addition to the observed and imputed values, we decided to do a further smoothing of the observed and imputed net values. So we began with net values for 196 physical activities. These were extracted from 137 pediatric studies and reflected over 37,000 observations. The 16 major categories are displayed here for very quiet, lying and sitting type of activities, standing, playing and sports, and on to walking and running at various speeds. The data was all subjected to these computations. The youth met was calculated as the energy cost of the specific activity taken from those various sources divided by the basal metabolic rate. And we decided to recalculate the net values based on a standardized basal metabolic rate using the Schofield equations, which are specific for age and sex and mass, which you can see here. And then this gives you an idea of what a typical tabulation of the data looked like. Again, these are the age groups, the 4 age groups, where we then put the mean value for that specific activity. And as you can see, there were several missing cells. And that's really not surprising because when you think of the literature, typically investigators do not study the entire age range from 5 to 18. So one study may be studying adolescents, another study may be studying school-age children. But again, there were several missing cells. And so the imputation was done. Initially, the statisticians examined the data to see if it was a better linear or quadratic fit. They decided after examining the R-squares that a linear fit was sufficient and therefore developed a mixed linear regression model to impute the missing values. And one thing that I thought was quite ingenious of the group is that they developed 16 imputation models. So, and each of the imputation models was done on one of the specific activity categories. So the missing values were imputed from activities which were very similar in nature. And so what we ended up with was 51% of the values were observed, taken from the literature, from those other sources, and 49% of the values were imputed. And in the next series of slides, I just want to give you a feel for the individual data, what it looked like. These are sitting categories where, for instance, in the first slide here, we have quiet play, schoolwork, and television. And we have plotted the measured values with a solid circle and the imputed values with the triangle. Each one of these lines represents a specific activity. It could be sitting and reading, playing dominoes, watching television. But again, these are all single activities within this category. And as you can see, as Karin was pointing out in her presentation, that the net value doesn't vary very much across age for this very sedentary activity. There's really no slope here. So one net value would actually be representative across the age groups. Similarly, with computer games in the sitting position, not much slope here, but you'll notice that there's quite a bit more variation amongst the values. And we think that's for 2 reasons. One, these points are coming from different laboratories that have used different procedures, different instructions for the children. But also, certain types of activities have a lot of input into how the child performs that activity. There's child volition, their skill level, etc. So you will see quite a bit of variability in these activities that tend to be more free living. Here's a series of activities in the standing category. And again, when it was quite quiet, quiet standing, not much of a slope between the youth MET value across the various age groups. But as you can see, as the activities get a bit more intense, you get to start to see this positive slope develop. So the MET values are very much lower in the younger age group compared to the teenagers. Here are the categories under play and sports. And again, you generally see a positive slope with the youth MET versus age. One kind of interesting exception to that is swimming, where there's a suggestion of a very slight negative correlation between age and the MET value. And we think that's probably due to the fact that the older children have a higher energy efficiency in swimming than the very young children. And lastly, we have walking and running. These measurements are done on a treadmill where the speed has been controlled. As you can see, from walking from 0.5 to 5 miles per hour and running 3 to 8 miles per hour. So it is not surprising that we see a lot less variation across the 4 age groups for the MET values. But again, you see a definitive positive slope with the MET value versus age. So we have from the very low speed of 3 miles per hour on up to 8 miles per hour. And as I said, our last step, a decision was made to do a further smoothing of the observed and imputed values. And again, you can see here with the observed and imputed values, there is quite a bit of variation across the age groups for any given specific activity. And again, we think that's methodological, and it's also due to the participants' volition in doing the activity. And so this last step, we smooth through the observed and imputed values, as you can see here. We believe that in most applications, probably the smooth MET values will be most useful. But there may be applications, particularly in research, where the investigator may really want to know which specific values were observed and imputed. And so in all of our materials, our publication, which is in MSSE, or in our website, all these values are available, both the observed and imputed, as well as the smooth values. And again, just to show you the comparison between the observed and the imputed values is shown here for dance, aerobics, and steps, and running. And you can see, again, we don't see quite as much variability in running, and so the smooth values are actually pretty close to the observed and imputed values. So we believe that the Youth Compendium will be a valuable resource for people working in pediatric exercise, but we also recognize that our Youth Compendium does have certain limitations. First, we believe that more data could be used for different populations, and specifically for very young children, less than 6 years of age, there's a need for more data. We did have some data on preschoolers, but it just was not sufficient to include it yet in the Youth Compendium. Data would be useful from groups differing in function and biomechanics, as well as groups varying in body mass index. And lastly, certain categories we noticed were lacking, and specifically more new data to be used for occupational activities in children, as well as graded activities, walking on a slope or running. And lastly, if there were more data available on the child characteristics, on how the activity was performed or the context in which it was performed, more sophisticated models could be developed for the prediction of MET values in children. So to sum up this section of our presentation, the Youth Compendium presents youth MET values for 196 activities across the 4 age categories. And we believe this will be quite useful for standardizing scoring and interpretation of youth physical activity in research and public health surveillance applications. And so I'll stop here and turn it over to Scott.
And just as we're turning to Scott, a reminder, if you have a question, please type it in. So after Scott, we'll have a question and answer session. So Scott, over to you.
All right, excellent. Good afternoon, everyone. So what I'm going to cover here in the last few minutes is the kind of application of the Youth Compendium, and also some limitations that come along with using it, and some guidance on some situations that might arise when you're trying to find values in the compendium. So I'm just going to briefly go through uses of it, how to use it, and some limitations within there. So in terms of using the Youth Compendium, there is wide reach for who might be using the Youth Compendium. Everything from researchers, public health officials, educators in a school setting, fitness professionals, and also the commercial sector can find uses for this also. A few examples. A lot of people will use this for energy expenditure from questionnaires, summarizing what the data they get there. It can be used in the aiding of development of evaluation programs, comparisons between school and community-based programs. Educators could use the Youth Compendium for lessons on things like energy balance, energy intake and output. And then also in the clinical setting, a lot of times there's issues related to activities that might be too vigorous for individuals. So in terms of clinical populations, identifying what they might not want to do versus what they do want to do. Currently, we have two primary sources of where you can find the compendium. And the first one is an open access article in Medicine and Science and Sports and Exercise. And there you can find the print version. You can find all the data from the summary data that's in the compendium online. Within this presentation coming up, I'm going to show you some of the online resources that we have available. And we have the website here for you to go to. So in terms of the website, if you haven't been there yet, I encourage you to go there. On the website, we have information related to the background and methods that's been covered within the webinar today. We also have a FAQ section where some common questions that might come up, you can try there first to see if we can answer them through that. And then there are, as we'll see in a minute, lookup tables where you can find the activities, and also you can, there's a download section. In terms of what you're going to see when you get into the compendium, there's a 6-digit code for each activity within the Youth Compendium. And again, we tried to set this up similar to the adult compendium just for consistency, because that's what people were used to. And so what you'll see is within the code, the first 2 digits, in this example here is 80, that will be for walking. And then the next 3 digits is for the specific activity. Here is 160, that's going to be walking at 2 miles an hour. And then the last digit available is going to be for the age group category. And you can see we have 4 age group categories, 6 to 9, 10 to 12, 13 to 15, and 16 to 18 years of age. Once you're within the compendium here, this is what it's going to look like if you were to go in and look at the values. What you will see is on all the MET codes on the left-hand side of your screen there'll be an X as the last digit. We put an X there just because we have all the MET values for each age group listed out. If you were to download this data, that X would get converted to what age group you're looking at. So there is a difference when you're viewing it online here. You can go in, you can view these activities by individual category, like what's on the screenshot here. You can just list all activities together. You can search for specific activities, so you can put in keywords and look at the activities that way also. Lastly, in terms of the website, you can go into the download section and you can download the data itself in a couple different formats. You can download the references that we've used through all this work. You can also gain access to the papers that have come out of the different reports that we have published on this with developing the correct metric and then how we develop the compendium and so forth. And then also there's other resources like the Schofield equation available there also. All right, so one question that comes up sometimes when looking at the compendium values, especially with how we did our age groups, is what do you do when you have a group of individuals that you're looking at? Let's say you're doing a PE class and they have an age and range that overlaps with our age group. So for example, you have a sample of 8 to 11-year-olds in your group. Ideally, it's going to be best to identify those that are 8 and 9-year-olds and get their MET value from the 6 to 9 age group, and then those that are 10 and 11 get the MET value from the 10 to 12-year age group. Sometimes this is not possible, especially when you're dealing with large groups. You might just have a general age range that you know of. So what we recommend doing in those cases is simply taking an average of the age group's MET values. So in a case like this, you would take the average of 2.8 for the 6 to 9 year age group, and then 10 to 12, you'd have a 3 MET value there. So for this group, you would use a 2.9 MET value. Another situation that could potentially occur is that you can't find the right activity in the compendium. As Nancy discussed, we are lacking some activities. And as the compendium grows over time, we will hopefully fill in those missing activities. But for now, the best approach is to try to find an activity that is similar to the activity you're trying to find. So, for example, one activity, when I was going through, we don't have raking leaves in there. And so the closest thing potentially in the compendium to raking leaves would be sweeping at kind of a moderate level. And so in this situation, you could substitute the MET value for sweeping for your raking leaves, keeping in mind that it's going to be an approximation. And I'm going to talk about this a little bit more in a second when I talk about limitations to using the compendium. So when we look at limitations to the compendium, the first thing that you want to keep in mind when using these values is that you're trying to use it to estimate the intensity or the energy cost during the activity time, not necessarily the time spent within a behavior. So an easier way to think about this is commonly on questionnaires, people will think about how long did I play basketball, and they might report that they played for 60 minutes. Most of the time you aren't playing basketball for that entire time. You might be sitting on the sideline for part of it. You might be actually only playing for half of it or less. When using the compendium values with a questionnaire, you go with what the questionnaire is giving you, so you don't change the validity of the questionnaire. But if possible, you want to try to get how much time were they actually active during their play time, rather than just using the total time. The other limitation within here is that, as has been discussed in the other two sections, is that these values don't do necessarily a good job of always taking into account differences between children and things like body mass or adiposity, economy of movement. Another big one is skill level when playing in an activity. And so with that in mind, it's important keep in mind the limitations of using the compendium to estimate energy expenditure. And so here, these two examples were used earlier. And here we have walking at 2 miles an hour on the top left and then basketball on the top right. And what you see is those blue dots there are the individual data points. And those individual data points, you can see for walking is fairly consistent, as was discussed earlier. But with basketball, there's quite a bit of variability within an age group in terms of energy costs. If you just look at the 6-year-olds for basketball, there's a range of roughly 3.8 METs upwards to almost 7 METs. And so when you start using this to predict energy expenditure, your estimates become very imprecise, especially on some of these more skill-based activities. And so in general, you want to try to use this for estimates of intensity level. So how much time spent is in NVPA versus trying to predict the energy cost directly. With that said, we know people are going to use this to predict energy expenditure. And so here's an example of how you could go about using the MET value to predict energy expenditure. And so it's simply to get the energy cost for the activity, you're going to take the MET value based on your age group. You're going to multiply that by the basal metabolic rate based on the Schofield equation, and then multiply it by how long they did the activity for. And in the example there, we have a 14-year-old girl weighing 40 kilograms, walking at 3 miles an hour for 20 minutes. And when you plug those numbers in, what you get is a total energy cost of roughly 73 kcals. Again, this is not intended to be an exact value, so use it with caution when you're looking at predicting energy costs. These are just rough estimates, so it is important to keep that in mind. And so with that, I'd like to wrap up. We've had, over the several years we've been working on this, several funders that have helped with this process, especially NCCOR and CDC and NCI. And so they've been generous in helping keep this process moving along. And with that, I will turn it back to questions.
Thank you so much, and thanks to all three of you, Karin, Nancy, and Scott. This is really exciting to see. It's been a culmination of a lot of hard work and wonderful presentations. So as a reminder, if you'd like to ask a question, please put it in the chat box where you can see that there are some participants with questions. And we'll just go straight to the question and answer session now. So let's start out with Matthew. Just wanted to know whether any of these studies included different ethnic backgrounds. Anyone want to take that on?
This is Scott. I can speak to that in terms of the UMass sample. There we had, it was roughly 20% Caucasian youth. The majority of our youth were Hispanic and then also African American. We had a large amount from the Caribbean area. So in terms of our sample, it was very diverse in that sense. I think with the other samples, it's really going to depend on the region that they were collected in. But overall, it was fairly representative in that respect.
Thank you, Scott. Karin, or anything else to add to what Scott has said? Anyone? Nancy? Okay, let's keep going. And so the next question is about the data collection in these studies. Was there any consistencies in the time of the year when data was collected?
This is Karin. I'll chime in. As far as I know, the data were collected at all different times of the year at all of the different sites. So And on top of that, nothing really incorporated being outside. These were laboratory-based studies. But they were collected essentially year-round.
Okay, thank you so much. And then Matthew asks, how many METs does a child need to lose weight? I know you're all hoping somebody else is going to answer this one. Karin, Nancy, and Scott.
I'll start.
Thanks.
Out again, I guess. So I think we have to be really cautious on that because there's a lot of variables that go into weight loss, and it's not just about a single MET value. Without really knowing more information about the individual in terms of their energy consumption and what type of activity they normally do, I don't think you can really say we need to expend X METs to get a weight loss. It's much more complex than that in a lot of sense. The MET values in terms of weight loss can be incorporated in terms of once you have an idea of the general makeup of the child and their energy intake, you can use the MET values to help set up an exercise prescription. So maybe they're going to go out and do a 30-minute walk at 3 miles an hour on one day, and then on another day you're going to have them do some type of sporting activity for X minutes. And you can use that to get kind of rough estimates of what their energy expenditure will be. But beyond that, I'm not sure what more we could do with that.
Thank you. That's not easy, Scott. So good advice. And somebody wanted to follow up on the earlier question about were there also, let's see, how, in addition to ethnic backgrounds, what about the socioeconomic background of samples? Was that considered?
This is Karin. That's a little more difficult to answer. It's people who live around universities who participated in these studies. So chances are most of them came from a somewhat middle-class background, although it's possible that some were higher and some were lower. But I'm not sure that we had, equal representation across different socioeconomic groups.
Okay, thank you. And so does anyone have advice for a program that may want to determine MET values for children who are younger than 6?
I guess I'll weigh in on that one again, too. I think that Nancy might be having difficulty hearing. So for those who are under the age of 5, at this point in time, we don't have any values compiled. We are hoping that in the future we will be able to actually obtain more data and extend down into that age group. So for now, I guess one solution is to simply use that youngest age group as a proxy. Although some of us do have ideas, we've collected these types of data kind of individual studies around, so you might be able to actually comb the literature and find some more common activities in there. But I think that's a future need that we would like to address as we revise the compendium moving forward.
Great, thank you. That'd be a great one to put on that future activity list. And one final question from Robert. What was the rationale for using the age group MET-Y values activity compared to the age-specific values?
I guess that's my part, so I should address that. So, we showed how using the child MET or youth MET value could help take away some of these effects of age in some of our energy expenditure estimates, but they couldn't fully do that. And so we used the age groups in order to better account for age. Now, why did we use age group versus age specific? They were actually quite similar to each other. It's simply really a feasibility decision. So we believe that researchers, for a lot of the activities in which researchers engage, they will probably download the age-specific values and use those themselves anyway. As a matter of, in an easier situation where you're just trying to get a quick estimate that might be more of a use that practitioners might engage in, because the age groups and the age in years approaches came out with very similar error, we took the age groups approach simply because it would be less values to deal with. You would be dealing with 4 values versus across that full age span. So it really was a feasibility issue.
Thank you so much. And I'm just going to, there's one more question that we'll just get to very quickly, as I know we're running out of time. In the schools where I work, there's been interest by students in life skills like archery and biking. So instead of varsity team traditional sports, we don't need specific data, but we want activities to at least break a sweat. Any ideas for life skills that will break a sweat, like archery, biking, gardening, or data on that somewhere? Is that in the compendium?
Okay, I guess I'll take that one too. So there are data for biking in the compendium, and there are probably a few other life skills that I cannot think of off the top of my head at this moment because there are several in there. However, there are things as a physical education kind of instructor, you are probably aware that you can even take an activity like archery that doesn't really expend much energy and add a little something to it, add some brisk walking into it, or do some things that could help to increase the energy expenditure level. There are other life skills that are kind of lifestyle activities in there. So you just kind of have to comb through, but there are some of those life skill kind of things included in there.
Great. Well, thank you so much, and I'm sorry we are out of time for more questions. Again, thank you so much, Karin, Nancy, and Scott. This has been really informative and really interesting. If you have questions about NCCOR or upcoming activities, please email the NCCOR Coordinating Center. You can see the address on the screen at ncor@fhi360.org. And follow us on Facebook, as we mentioned at the start, at ncor.org. And to find out more about upcoming webinars, you can access the webinar section of the website on the top navigation. Click on webinars. You'll see a schedule of what's coming up next, and also all of the archived webinars. If you have peers who did not have a chance to participate today, please let them know that they can still hear it. So thank you to our guest speakers, and before signing off, thank you to participants, and please take a moment to complete our brief survey. Your responses help shape future webinars, so we really want to know how best to use your time.